Yes, added Barbicane, as soon as we shall have passed the neutral point, the base of the projectile, its heaviest part, will swing around gradually until it faces the moon. Before this phenomenon, however, can take place, we must of course cross the line. Cross the line, cried the Frenchman. Then let us imitate the sailors when they do the same thing in the Atlantic Ocean, splice the main brace. A slight effort carried him sailing over to the side of the projectile. Opening a cupboard and taking out a bottle and a few glasses, he placed them on a tray. Then setting the tray itself in the air as on a table in front of his companions, he filled the glasses, passed them around, and in a lively speech interrupted with many a joyous hurrah, congratulated his companions on their glorious achievement in being the first that ever crossed the lunar line. This counteracting influence of the attractions lasted nearly an hour. By that time the travellers could keep themselves on the floor without much effort. Barbicane also made his companions remark that the conical point of the projectile diverged a little from the direct line to the moon, while by an inverse movement, as they could notice through the window of the floor, the base was gradually turning away from the earth. The lunar attraction was evidently getting the better of the terrestrial. The fall towards the moon, though still almost insensible, was certainly beginning. It could not be more than the 80th part of an inch in the first second. But by degrees, as the attractive force would increase, the fall would be more decided, and the projectile, overbalanced by its base and presenting its cone to the earth, would descend with accelerated velocity to the lunar surface. The object of their daring attempt would then be successfully attained. No further obstacle, therefore, being likely to stand in the way of the complete success of the enterprise, the captain and the Frenchman cordially shook hands with Barbicane. All kept congratulating each other on their good fortune as long as the battle lasted. They could not talk enough about the wonderful phenomenon lately witnessed. The chief point, the neutralization of the law of gravity, particularly, supplied them with an inexhaustible subject. The Frenchman, as usual, as enthusiastic in his fancy as he was fanciful in his enthusiasm, got off some characteristic remarks. "What a fine thing it would be, my boys," he exclaimed, "if on earth we could be so fortunate as we have been here, and get rid of that weight that keeps us down like lead, that rivets us to it like an adamantine chain. Then should we prisoners become free. Adieu forever to all weariness of arms or feet. At present, in order to fly over the surface of the earth by the simple exertion of our muscles, or even to sustain ourselves in the air, we require a muscular force 50 times greater than we possess. But if attraction did not exist, the simplest act of the will, our slightest whim even, would be sufficient to transport us to whatever part of space we wished to visit." "Arden, you had better invent something to kill attraction," observed 1000 Nicholl dryly. "You can do it if you try. Jackson and Morton have killed pain by sulfuric ether. Suppose you try your hand on attraction." "It would be worth a trial," cried Arden, so full of his subject as not to notice the captain's jeering tone. "Attraction once destroyed, there is an end forever to all loads, packs, and burdens. How the poor omnibus horses would rejoice. Adieu forever to all cranes, derricks, capstans, jackscrews, and even hotel elevators. We could dispense with all ladders, doorsteps, and even staircases." "And with all houses too," interrupted Barbicane. "Or, at least, we should dispense with them because we could not have them. If there was no weight, you could neither make a wall of bricks nor cover your house with a roof. Even your hat would not stay on your head, the cars would not stay on the railway nor the boats on the water. What do I say? We could not have any water. Even the ocean would leave its bed and float away into space. Nay, the atmosphere itself would leave us, being detained in its place by terrestrial attraction and by nothing else." "Too true, Mr. President," replied Arden after a pause. "It's a fact. I acknowledge the corn, as Marston says, but how you positive fellows do knock holes into our pretty little creations of fancy." "Don't feel so bad about it, Arden," observed 1000 Nicholl. "Though there may be no orb from which gravity is excluded altogether, we shall soon land in one where it is much less powerful than on the earth." "You mean the moon's?" "Yes, the moon. Her mass being 189 of the earth's, her attractive power should be in the same proportion. That is, a boy 10 years old, whose weight on earth is about 90 pounds, would weigh on the moon only about 1 pound, if nothing else were to be taken into consideration. But when standing on the surface of the moon, he is relatively 4 times nearer to the center than when he is standing on the surface of the earth. His weight, therefore, having to be increased by the square of the distance, must be 16 times greater. Now 16 times 189 being less than 1/5, it is clear that my weight of 150 pounds will be cut down to nearly 30 as soon as we reach the moon's surface." "And mine?" asked Arden. "Yours will hardly reach 25 pounds, I should think," was the reply. "Shall my muscular strength diminish in the same proportion?" was the next question. "On the contrary, it will be relatively so much the more increased that you can take a stride 15 feet in width, as easily as you can now take one of ordinary length." "We shall be all Samsons then in the moon," cried Arden. "Especially," replied 1000 Nicholl, "if the stature of the Selenites is in proportion to the mass of their globe." "If so, what should be their height?" "A tall man would hardly be 12 inches in his boots." "They must be veritable Lilliputians then," cried Arden, "and we are all to be Gullivers, the old myth of the giants realized. Perhaps the Titans that played such famous parts in the prehistoric period of our Earth were adventurers like ourselves, casually arrived from some great planet." "Not from such planets as Mercury, Venus or Mars anyhow, friend Michael," observed Barbicane. "But the inhabitants of Jupiter, Saturn, Uranus or Neptune, if they bear the same proportion to their planet that we do ours, must certainly be regular Brobdignagians." "Let us keep severely away from all planets of the latter class then," said Arden. "I never liked to play the part of Lilliputian myself, but how about the sun, Barbicane? I always had a hankering after the sun." "The sun's volume is about 113 million times greater than that of the Earth, but his density being only about 1/4, the attraction on his surface is hardly 30 times greater than that of our globe. Still, every proportion observed, the inhabitants of the sun can't be much less than 150 or 160 feet in height." "Miltoneras," cried Arden, "I should be there like Ulysses among the Cyclops. I'll tell you what it is, Barbicane, if we ever decide on going to the sun, we must provide ourselves beforehand with a few of your Rodman's columbiads to frighten off the Solarians." "Your columbiads would not do great execution there," observed 1000 Nicholl. "Your bullet would be hardly out of the barrel when it would drop to the surface like a heavy stone pushed off the wall of a house." "Oh, I like that," laughed the incredulous Arden. "A little calculation, however, shows the captain's remark to be perfectly just," said Barbicane. "Rodman's ordinary 15-inch columbiad requires a charge of 100 pounds of mammoth powder to throw a ball of 500 pounds weight. What could such a charge do with a ball weighing 30 times as much or 15,000 pounds? Reflect on the enormous weight everything must have on the surface of the sun. Your hat, for instance, would weigh 20 or 30 pounds, your cigar nearly a pound. In short, your own weight on the sun's surface would be so great, more than 2 tons, that if you ever fell you should never be able to pick yourself up again." "Yes," added the captain, "and whenever you wanted to eat or drink you should rig up a set of powerful machinery to hoist the eatables and drinkables into your mouth." "Enough of the sun today, boys," cried Arden, shrugging his shoulders. "I don't contemplate going there at present. Let us be satisfied with the moon. There at least we shall be of some account." Chapter 9. A little off the track. Barbicane's mind was now completely at rest, at least on one subject. The original force of the discharge had been great enough to send the projectile beyond the neutral line. Therefore, there was no longer any danger of its falling back to the earth. Therefore, there was no longer any danger of its resting eternally motionless on the point of the counteracting attractions. The next subject to engage his attention was the question: would the projectile, under the influence of lunar attraction, succeed in reaching its destination? The only way in which it could succeed was by falling through a space of nearly 24,000 miles, and then striking the moon's surface. A most terrific fall, even taking the lunar attraction to be only the 1/6 of the Earth's. Such a fall was simply bewildering to think of. The greatest height to which a balloon ever ascended was 7 miles, Glacier, 1862. Imagine a fall from even that distance, then imagine a fall from a height of 4,000 miles. Yet it was for a fall of this appalling kind on the surface of the moon that the travellers had now to prepare themselves. Instead of avoiding it, however, they eagerly desired it, and would be very much disappointed if they missed it. They had taken the best precautions they could devise to guard against the terrific shock. These were mainly of 2 kinds. One was intended to counteract as much as possible the fearful results to be expected the instant the projectile touched the lunar surface. The other, to retard the velocity of the fall itself, and thereby to render it less violent. The best arrangement of the first kind was certainly Barbican's water contrivance for counteracting the shock at starting, which has been so fully described in our former volume. See Baltimore Gun Club, page 353, but unfortunately it could be no longer employed. Even if the partitions were in working order, the water, 2,000 pounds in weight had been required, was no longer to be had. The little still left in the tanks was of no account for such a purpose. Besides, they had not a single drop of the precious liquid to spare, for they were as yet anything but sanguine regarding the facility of finding water on the moon's surface. Fortunately, however, as the gentle reader may remember, Barbican, besides using water to break the concussion, had provided the movable disc with stout pillars containing a strong buffing apparatus, intended to protect it from striking the bottom too violently after the destruction of the different partitions. These buffers were still good, and gravity being as yet almost imperceptible, to put them once more in order and adjust them to the disc was not a difficult task. The travellers set to work at once and soon accomplished it. The different pieces were put together readily, a mere matter of bolts and screws, with plenty of tools to manage them. In a short time the repaired disc rested on its steel buffers, like a table on its legs, or rather like a sofa seat on its springs. The new arrangement was attended with at least one disadvantage, the bottom light being covered up. A convenient view of the moon's surface could not be had as soon as they should begin to fall in a perpendicular descent. This, however, was only a slight matter, as the side lights would permit the adventurers to enjoy quite as favourable a view of the vast regions of the moon as is afforded to balloon travellers when looking down on the earth over the sides of their car. The disc arrangement was completed in about an hour, but it was not till past 12 o'clock before things were restored to their usual order. Barbican then tried to make fresh observations regarding the inclination of the projectile, but to his very decided chagrin, he found that it had not yet turned over sufficiently to commence the perpendicular fall. On the contrary, it even seemed to be following a curve rather parallel with that of the lunar disc. The Queen of the Stars now glittered with a light more dazzling than ever, whilst from an opposite part of the sky the glorious King of Day flooded her with his fires. The situation began to look a little serious. "Shall we ever get there?" asked the captain. "Let us be prepared for getting there anyhow," was Barbican's dubious reply. "You're a pretty pair of suspenders," said Arden cheerily. He meant of course doubting hesitators, but his fluent command of English sometimes led him into such solecisms. "Certainly we shall get there, and perhaps a little sooner than will be good for us." This reply sharply recalled Barbican to the task he had undertaken, and he now went to work seriously, trying to combine arrangements to break the fall. The reader may perhaps remember Arden's reply to the captain on the day of the famous meeting in Tampa. "Your fall would be violent enough," the captain had urged, "to splinter you like glass into 1,000 fragments." "And what shall prevent me," had been Arden's ready reply, "from breaking my fall by means of counteracting rockets suitably disposed, and let off at the proper time?" The practical utility of this idea had at once impressed Barbican. It could hardly be doubted that powerful rockets, fastened on the outside to the bottom of the projectile, could, when discharged, considerably retard the velocity of the fall by their sturdy recoil. They could burn in a vacuum by means of oxygen furnished by themselves, as powder burns in the chamber of a gun, or as the volcanoes of the moon continue their action regardless of the absence of a lunar atmosphere. Barbican had therefore provided himself with rockets enclosed in strong steel gun barrels, grooved on the outside so that they could be screwed into corresponding holes already made with much care in the bottom of the projectile. They were just long enough, when flush with the floor inside, to project outside by about 6 inches. They were 20 in number, and formed 2 concentric circles around the dead light. Small holes in the disc gave admission to the wires by which each of the rockets was to be discharged externally by electricity. The whole effect was therefore to be confined to the outside. The mixtures having been already carefully deposited in each barrel, nothing further need be done than to take away the metallic plugs which had been screwed into the bottom of the projectile, and replace them by the rockets, every one of which was found to fit its grooved chamber with rigid exactness. This evidently should have been all done before the disc had been finally laid on its springs, but as this had to be lifted up again in order to reach the bottom of the projectile, more work was to be done than was strictly necessary, though the labour was not very hard, considering that gravity had as yet scarcely made itself felt. 1,000 Nicholl and Arden were not sorry to have their little joke at Barbican's expense. The Frenchman began humming, "Aliquendoc bonus dormitat humorous." to a tune from Orpheus in Furs, and the captain said something about the Philadelphia highway commissioners who pave a street one day and tear it up the next to lay the gas pipes. But his friend's humour was all lost on Barbicane, who was so wrapped up in his work that he probably never heard a word they said. Towards 3 o'clock every preparation was made, every possible precaution taken, and now our bold adventurers had nothing more to do than watch and wait. The projectile was certainly approaching the moon. It had by this time turned over considerably under the influence of attraction, but its own original motion still followed a decidedly oblique direction. The consequence of these two forces might possibly be a tangent line approaching the edge of the moon's disk. One thing was certain: the projectile had not yet commenced to fall directly towards her surface. Its base, in which its centre of gravity lay, was still turned away considerably from the perpendicular. Barbicane's countenance soon showed perplexity and even alarm. His projectile was proving intractable to the laws of gravitation. The unknown was opening out dimly before him, the great boundless unknown of the starry plains. In his pride and confidence as a scientist, he had flattered himself with having sounded the consequence of every possible hypothesis regarding the projectile's ultimate fate: the return to the earth, the arrival at the moon, and the motionless dead stop at the neutral point. But here a new and incomprehensible fourth hypothesis, big with the terrors of the mystic infinite, rose up before his disturbed mind, like a grim and hollow ghost. After a few seconds, however, he looked at it straight in the face without wincing. His companions showed themselves just as firm. Whether it was science that emboldened Barbicane, his phlegmatic stoicism that propped up the captain, or his enthusiastic vivacity that cheered the irrepressible Arden, I cannot exactly say. But certainly, they were all soon talking over the matter as calmly as you or I would discuss the advisability of taking a sail on the lake some beautiful evening in July. Their first remarks were decidedly peculiar and quite characteristic. Other men would have asked themselves where the projectile was taking them to. Do you think such a question ever occurred to them? Not a bit of it. They simply began asking each other what could have been the cause of this new and strange state of things. "Off the track, it appears," observed Arden. "How's that?" "My opinion is," answered the captain, "that the projectile was not aimed true. Every possible precaution had been taken, I am well aware, but we all know that an inch, a line, even the 10th part of a hair's breadth wrong at the start would have sent us thousands of miles off our course by this time." "What have you to say to that, Barbicane?" asked Arden. "I don't think there was any error at the start," was the confident reply. "Not even so much as a line. We took too many tests proving the absolute perpendicularity of the Columbiad to entertain the slightest doubt on that subject. Its direction towards the zenith being incontestable, I don't see why we should not reach the moon when she comes to the zenith." "Perhaps we're behind time," suggested Arden. "What have you to say to that, Barbicane?" asked the captain. "You know the Cambridge men said the journey had to be done in 97 hours 13 minutes and seconds. That's as much as to say that if we're not up to time we shall miss the moon." "Correct," said Barbicane, "but we can't be behind time. We started, on December 1st at 13 minutes and seconds before 11 o'clock, and we were to arrive 4 days later at midnight precisely. Today is December 5th, gentlemen. Please examine your watches. It is now 3:30 in the afternoon. 8 hours and a half are sufficient to take us to our journey's end. Why should we not arrive there?" "How about being ahead of time?" asked the captain. "Just so," said Arden. We have discovered the initial velocity to have been greater than was expected." "Not at all, not at all," cried Barbicane. "A slight excess of velocity would have done no harm whatever had the direction of the projectile been perfectly true. No, there must have been a digression. We must have been switched off." "Switched off by what?" asked both his listeners in one breath. "I can't tell," said Barbicane curtly. "Well," said Arden, "if Barbicane can't tell, there is an end to all further talk on the subject. We're switched off, that's enough for me. What has done it? I don't care. Where are we going to? I don't care. What is the use of pestering our brains about it? We shall soon find out. We are floating around in space, and we shall end by hauling up somewhere or other." But in this indifference Barbicane was far from participating. Not that he was not prepared to meet the future with a bold and manly heart. It was his inability to answer his own question that rendered him uneasy. What had switched them off? He would have given worlds for an answer, but his brain, sorely puzzled, sought one in vain. In the meantime, the projectile continued to turn its side, rather than its base towards the moon. That is, to assume a lateral rather than a direct movement, and this movement was fully participated in by the multitude of the objects that had been thrown outside. Barbicane could even convince himself by citing several points on the lunar surface, by this time hardly more than 15 or 18,000 miles distant, that the velocity of the projectile, instead of accelerating, was becoming more and more uniform. This was another proof that there was no perpendicular fall. However, though the original impulsive force was still superior to the moon's attraction, the travelers were evidently approaching the lunar disk, and there was every reason to hope that they would at last reach a point where, the lunar attraction at last having the best of it, a decided fall should be the result. The three friends, it need hardly be said, continued to make their observations with redoubled interest, if redoubled interest were possible. But with all their care, they could as yet determine nothing regarding the topographical details of our radiant satellite. Her surface still reflected the solar rays too dazzlingly to show the relief necessary for satisfactory observation. Our travelers kept steadily on the watch, looking out of the side lights, till 8 o'clock in the evening, by which time the moon had grown so large in their eyes that she covered up fully half the sky. At this time the projectile itself must have looked like a streak of light, reflecting, as it did, the sun's brilliancy on the one side and the moon's splendor on the other. Barbicane now took a careful observation, and calculated that they could not be much more than 2,000 miles from the object of their journey. The velocity of the projectile he calculated to be about 650 feet per second, or 450 miles an hour. They had therefore still plenty of time to reach the moon in about 4 hours, but though the bottom of the projectile continued to turn towards the lunar surface in obedience to the law of centripetal force, the centrifugal force was still evidently strong enough to change the path which it followed into some kind of curve, the exact nature of which would be exceedingly difficult to calculate. The careful observations that Barbicane continued to take did not, however, prevent him from endeavoring to solve his difficult problem. What had switched them off? The hours passed on but brought no result. That the adventurers were approaching the moon was evident, but it was just as evident that they should never reach her. The nearest point the projectile could ever possibly attain would only be the result of two opposite forces, the attractive and the repulsive, which, as was now clear, influenced its motion. Therefore, to land in the moon was an utter impossibility, and any such idea was to be given up at once and forever. "Quond meme, what of it?" cried Arden after some moments' silence. "We're not to land in the moon. Well, let us do the next best thing, pass close enough to discover her secrets." But 1000 Nicholl could not accept the situation so coolly. On the contrary, he decidedly lost his temper, as is occasionally the case with even phlegmatic men. He muttered an oath or two, but in a voice hardly loud enough to reach Barbicane's ear. At last, impatient of further restraint, he burst out. "Who the deuce cares for her secrets? To the hangman with her secrets. We started to land in the moon. That's what's got to be done. That I want or nothing. Confound the darned thing, I say, whatever it was, whether on the earth or off it, that shoved us off the track." "On the earth or off it," cried Barbicane, striking his head suddenly. "Now I see it. You're right, Captain. Confound the bolide that we met the first night of our journey." "Hey," cried Ardens. "What do you mean?" asked 1000 Nicholl. "I mean," replied Barbicane, with a voice now perfectly calm, and in a tone of quiet conviction, "that our deviation is due altogether to that wandering meteor." "Why, it did not even graze us," cried Arden. "No matter for that," replied Barbicane. "Its mass, compared to ours, was enormous, and its attraction was undoubtedly sufficiently great to influence our deviation." "Hardly enough to be appreciable," urged 1000 Nicholl. "Right again, Captain," observed Barbicane. "But just remember an observation of your own made this very afternoon. An inch, a line, even the 10th part of a hair's breadth wrong at the beginning, in a journey of 240,000 miles, would be sufficient to make us miss the moon." Chapter 10. The Observers of the Moon. Barbicane's happy conjecture had probably hit the nail on the head. The divergency even of a second may amount to millions of miles if you only have your lines long enough. The projectile had certainly gone off its direct course. Whatever the cause, the fact was undoubted. It was a great pity. The daring attempt must end in a failure due altogether to a fortuitous accident, against which no human foresight could have possibly taken precaution. Unless, in case of the occurrence of some other most improbable accident, reaching the moon was evidently now impossible. To failure, therefore, our travellers had to make up their minds. but was nothing to be gained by the trip. Though missing actual contact with the moon, might they not pass near enough to solve several problems in physics and geology over which scientists had been for a long time puzzling their brains in vain? Even this would be some compensation for all their trouble, courage, and intelligence. As to what was to be their own fate, to what doom were themselves to be reserved, they never appeared to think of such a thing. They knew very well that in the midst of those infinite solitudes they should soon find themselves without air. The slight supply that kept them from smothering could not possibly last more than 5 or 6 days longer. 5 or 6 days? What of that? Quond meme, as Arden often exclaimed. 5 or 6 days were centuries to our bold adventurers. At present every second was a year in events, and infinitely too precious to be squandered away in mere preparations for possible contingencies. The moon could never be reached, but was it not possible that her surface could be carefully observed? This they set themselves at once to find out. The distance now separating them from our satellite they estimated at about 400 miles. Therefore, relatively to their power of discovering the details of her disk, they were still farther off from the moon than some of our modern astronomers are today, when provided with their powerful telescopes. We know, for example, that Lord Rosse's great telescope at Parsonstown, possessing a power of magnifying 6,000 times, brings the moon to within 40 miles of us, not to speak of Barbican's great telescope on the summit of Long's Peak, by which the moon, magnify 0 times, was brought within 5 miles of the earth, where it therefore could reveal with sufficient distinctness every object above 40 feet in diameter. Therefore our adventurers, though at such a comparatively small distance, could not make out the topographical details of the moon with any satisfaction by their unaided vision. The eye indeed could easily enough catch the rugged outline of these vast depressions improperly called seas, but it could do very little more. Its powers of adjustability seemed to fail before the strange and bewildering scene. The prominence of the mountains vanished, not only through the foreshortening, but also in the dazzling radiation produced by the direct reflection of the solar rays. After a short time, therefore, completely foiled by the blinding glare, the eye turned itself unwillingly away, as if from a furnace of molten silver. The spherical surface, however, had long since begun to reveal its convexity. The moon was gradually assuming the appearance of a gigantic egg, with the smaller end turned towards the earth. In the earlier days of her formation, while still in a state of mobility, she had been probably a perfect sphere in shape. But, under the influence of terrestrial gravity operating for uncounted ages, she was drawn at last so much towards the center of attraction as to resemble somewhat a prolate spheroid. By becoming a satellite, she had lost the native perfect regularity of her outline. Her center of gravity had shifted from her real center, and as a result of this arrangement, some scientists have drawn the conclusion that the moon's air and water have been attracted to that portion of her surface which is always invisible to the inhabitants of the earth. The convexity of her outline, this bulging prominence of her surface, however, did not last long. The travelers were getting too near to notice it. They were beginning to survey the moon as balloonists survey the earth. The projectile was now moving with great rapidity, with nothing like its initial velocity, but still 8 or 9 times faster than an express train. Its line of movement, however, being oblique instead of direct, was so deceptive as to induce Arden to flatter himself that they might still reach the lunar surface. He could never persuade himself to believe that they should get so near their aim and still miss it. No, nothing might, could, would, or should induce him to believe it, he repeated again and again, but Barbican's pitiless logic left him no reply. No, dear friend, no. We can reach the moon only by a fall, and we don't fall. Centripetal force keeps us at least for a while under the lunar influence, but centrifugal force drives us away irresistibly. These words were uttered in a tone that killed Arden's last and fondest hope. The portion of the moon they were now approaching was her northern hemisphere, found usually in the lower part of lunar maps. The lens of a telescope, as is well known, gives only the inverted image of the object. Therefore, when an upright image is required, an additional glass must be used. But as every additional glass is an additional obstruction to the light, the object glass of a lunar telescope is employed without a corrector. Light is thereby saved, and in viewing the moon, as in viewing a map, it evidently makes very little difference whether we see her inverted or not. Maps of the moon, therefore, being drawn from the image formed by the telescope, show the north in the lower part and vice versa. Of this kind was the Mappa Selenographica by Beer and Meidler, so often previously alluded to and now carefully consulted by Barbican. The northern hemisphere, towards which they were now rapidly approaching, presented a strong contrast with the southern, by its vast plains and great depressions, checkered here and there by very remarkable isolated mountains. At midnight the moon was full. This was the precise moment at which the travellers would have landed, had not that unlucky bolide drawn them off the track. The moon was therefore strictly up to time, arriving at the instant rigidly determined by the Cambridge Observatory. She occupied the exact point, to a mathematical nicety, where our 28th parallel crossed the perigee. An observer posted in the bottom of the Columbiad at Stony Hill would have found himself at this moment precisely under the moon. The axis of the enormous gun, continued upwards vertically, would have struck the orb of night exactly in her centre. It is hardly necessary to tell our readers that, during this memorable night of the 5th of December, the travellers had no desire to close their eyes. Could they do so, even if they had desired? No, all their faculties, thoughts and desires were concentrated in one single word. Look, representatives of the earth, and of all humanity past and present, they felt that it was with their eyes that the race of man contemplated the lunar regions and penetrated the secrets of our satellite. A certain indescribable emotion, therefore, combined with an undefined sense of responsibility, held possession of their hearts, as they moved silently from window to window. Their observations, recorded by Barbicane, were vigorously remade, revised, and redetermined by the others. To make them, they had telescopes which they now began to employ with great advantage. To regulate and investigate them, they had the best maps of the day. Whilst occupied in this silent work, they could not help throwing a short retrospective glance on the former observers of the moon. The first of these was Galileo. His slight telescope magnified only 30 times, still in the spots flecking the lunar surface like the eyes checkering a peacock's tail, he was the first to discover mountains and even to measure their heights. These, considering the difficulties under which he laboured, were wonderfully accurate, but unfortunately he made no map embodying his observations. A few years afterwards, Hevel of Danzig, 1611–1688, a Polish astronomer, more generally known as Hevelius, his works being all written in Latin, undertook to correct Galileo's measurements. But as his method could be strictly accurate only twice a month, the periods of the first and second quadratures, his rectifications could be hardly called successful. Still it is to the labours of this eminent astronomer, carried on uninterruptedly for 50 years in his own observatory, that we owe the first map of the moon. It was published in 1647 under the name of Selenographia. He represented the circular mountains by open spots somewhat round in shape, and by shaded figures he indicated the vast plains, or, as he called them, the seas, that occupied so much of her surface. These he designated by names taken from our earth. His map shows you a Mount Sinai the midst of an Arabia, an Atna in the centre of a Sicily, Alps, Apennines, Carpathians, a Mediterranean, a Palus Aealis, a Pontus Euxinus, and a Caspian Sea. But these names seem to have been given capriciously, and at random, for they never recall any resemblance existing between themselves and their namesakes on our globe. In the wide open spot, for instance, connected on the south with vast continents and terminating in a point, it would be no easy matter to recognize the reversed image of the Indian peninsula, the Bay of Bengal and Cochin China. Naturally, therefore, these names were nearly all soon dropped, but another system of nomenclature, proposed by an astronomer better acquainted with the human heart, met with a success that has lasted to the present day. This was Father Riccioli, a Jesuit, and 1598–1671, a contemporary of Hevelius. In his Astronomia Reformata, 1665, he published a rough and incorrect map of the moon, compiled from observations made by Grimaldi of Ferrara, but in designating the mountains, he named them after eminent astronomers, and this idea of his has been carefully carried out by map-makers of later times. A third map of the moon was published at Rome in 1666 by Domenico Cassini of Nice, 1625–1712, the famous discoverer of Saturn's satellites. Though somewhat incorrect regarding measurements, it was superior to Riccioli's in execution, and for a long time it was considered a standard work. Copies of this map are still to be found, but Cassini's original copperplate, preserved for a long time at the Imprimerie Reale in Paris, was at last sold to a brazier, by no less a personage than the director of the establishment himself, who, according to Arago, wanted to get rid of what he considered useless lumber. La Hire, 1640–1718, professor of astronomy in the Collège de France and an accomplished draftsman, drew a map of the moon which was 13 feet in diameter. This map could be seen long afterwards in the library of St. Genevieve, Paris, but it was never engraved. About 1760, Mayer, a famous German astronomer and the director of the Observatory of Göttingen, began the publication of a magnificent map of the moon, drawn after lunar measurements all rigorously verified by himself. Unfortunately, his death in 1762 interrupted a work which would have surpassed in accuracy every previous effort of the kind. Next appears Schroeder of Erfurt, 1745–1816. A fine observer, he first discovered the lunar rills, but a poor draftsman. His maps are therefore of little value. Lohrmann of Dresden published in 1838 an excellent map of the moon, 15 inches in diameter, accompanied by descriptive text and several charts of particular portions on a larger scale. But this and all other maps were thrown completely into the shade by Beer and Meidler's famous Mappa Selenographica, so often alluded to in the course of this work. This map, projected orthographically, that is, one in which all the rays proceeding from the surface to the eye are supposed to be parallel to each other, gives a reproduction of the lunar disk exactly as it appears. The representation of the mountains and plains is therefore correct only in the central portion. Elsewhere, north, south, east, or west, the features, being foreshortened, are crowded together, and cannot be compared in measurement with those in the center. It is more than 3 feet square. For convenient reference, it is divided into 4 parts, each having a very full index. In short, this map is in all respects a masterpiece of lunar cartography. After Beer and Meidler, we should allude to Julius Schmidt's of Athens' excellent selenographic reliefs, to Dr. Draper's and to Father Secchi's successful application of photography to lunar representation, to de la Rue's of London, magnificent stereographs of the moon to be had at every optician's, to the clear and correct map prepared by Lecouturier and Chapuis in 1860, to the many beautiful pictures of the moon in various phases of illumination obtained by the Messrs. Bond of Harvard University, to Rutherford's of New York unparalleled lunar photographs, and finally to Nasmyth and Carpenter's wonderful work on the moon, illustrated by photographs of her surface in detail, prepared from models at which they had been laboring for more than a quarter of the century. Of all these maps, pictures, and projections, Barbicane had provided himself with only 2, Beer and Meidler's in German, and Lecouturier and Chapuis in French. These he considered quite sufficient for all purposes, and certainly they considerably simplified his labors as an observer. His best optical instruments were several excellent marine telescopes, manufactured especially under his direction. Magnifying the object 100 times, on the surface of the earth, they would have brought the moon to within a distance of somewhat less than 2,400 miles, but at the point to which our travelers had arrived towards 3 o'clock in the morning, and which could hardly be more than 12 or 1,300 miles from the moon, these telescopes, ranging through a medium disturbed by no atmosphere, easily brought the lunar surface to within less than 13 miles distance from the eyes of our adventurers. Therefore they should now see objects in the moon as clearly as people can see the opposite bank of a river that is about 12 miles wide. Chapter 11. Fact and Fancy. "Have you ever seen the moon?" said a teacher ironically one day in class to one of his pupils. "No, sir," was the pert reply, "but I think I can safely say I've heard it spoken about." Though saying what he considered a smart thing, the pupil was probably perfectly right. Like the immense majority of his fellow beings, he had looked at the moon, heard her talked of, written poetry about her, but in the strict sense of the term he had probably never seen her. That is, scanned her, examined her, surveyed her, inspected her, reconnoitred her, even with an opera glass. Not one in 1,000, not one in 10,000, has ever examined even the map of our only satellite. To guard our beloved and intelligent reader against this reproach, we have prepared an excellent reduction of Beer and Meidler's Mappa, on which, for the better understanding of what is to follow, we hope he will occasionally cast a gracious eye. When you look at any map of the moon, you are struck first of all with one peculiarity. Contrary to the arrangement prevailing in Mars and on our Earth, the continents occupy principally the southern hemisphere of the lunar orb. Then these continents are far from presenting such sharp and regular outlines as distinguish the Indian Peninsula, Africa, and South America. On the contrary, their coasts, angular, jagged, and deeply indented, abound in bays and peninsulas. They remind you of the coast of Norway, or of the islands in the Sound, where the land seems to be cut up into endless divisions. If navigation ever existed on the moon's surface, it must have been of a singularly difficult and dangerous nature, and we can scarcely say which of the two should be more pitied, the sailors who had to steer through these dangerous and complicated passes, or the map-makers who had to designate them on their charts. You will also remark that the southern pole of the moon is much more continental than the northern. Around the latter, there exists only a slight fringe of lands, separated from the other continents by vast seas. This word seas, a term employed by the first lunar map constructors, is still retained to designate those vast depressions on the moon's surface, once perhaps covered with water, though they are now only enormous plains. In the south, the continents cover nearly the whole hemisphere. It is therefore possible that the Selenites have planted their flag on at least one of their poles, whereas the Perrys and Franklins of England, the Kanes and the Wilkeses of America, the Dumont d'Urvilles and the Lamberts of France, have so far met with obstacles completely insurmountable, while in search of those unknown points of our terrestrial globe. The islands, the next feature on the moon's surface, are exceedingly numerous, generally oblong or circular in shape, and almost as regular in outline as if drawn with a compass. They form vast archipelagos like the famous group lying between Greece and Asia Minor, which mythology has made the scene of her earliest and most charming legends. As we gaze at them, the names of Naxos, Tenedos, Milo, and Carpathos rise up before our mind's eye, and we begin looking around for the Trojan fleet and Jason's Argo. This, at least, was Arden's idea, and at first his eyes would see nothing on the map but a Grecian archipelago, but his companions, sound practical men, and therefore totally devoid of sentiment, were reminded by these rugged coasts of the beetling cliffs of New Brunswick and Nova Scotia. So that, where the Frenchmen saw the tracks of ancient heroes, the Americans saw only commodious shipping points and favorable sites for trading posts, all, of course, in the purest interest of lunar commerce and industry. To end our hasty sketch of the continental portion of the moon, we must say a few words regarding her orthography or mountain systems. With a fair telescope you can distinguish very readily her mountain chains, her isolated mountains, her circuses or ring formations, and her rills, cracks and radiating streaks. The character of the whole lunar relief is comprised in these divisions. It is a surface prodigiously reticulated, upheaved and depressed, apparently without the slightest order or system. It is a vast Switzerland, an enormous Norway, where everything is the result of direct plutonic action. This surface, so rugged, craggy and wrinkled, seems to be the result of successive contractions of the crust, at an early period of the planet's existence. The examination of the lunar disk is therefore highly favorable for the study of the great geological phenomena of our own globe. As certain astronomers have remarked, the moon's surface, though older than the Earth's, has remained younger. That is, it has undergone less change. No water has broken through its rugged elevations, filled up its scowling cavities, and by incessant action tended continuously to the production of a general level. No atmosphere, by its disintegrating, decomposing influence has softened off the rugged features of the plutonic mountains. Volcanic action alone, unaffected by either aqueous or atmospheric forces, can here be seen in all its glory. In other words, the moon looks now as our Earth did endless ages ago, when she was void and empty, and when darkness sat upon the face of the deep. Eons of ages ago, long before the tides of the ocean and the winds of the atmosphere had begun to strew her rough surface with sand and clay, rock and coal, forest and meadow, gradually preparing it, according to the laws of our beneficent Creator, to be at last the pleasant though the temporary abode of man. Having wandered over vast continents, your eye is attracted by the seas of dimensions still vaster. Not only their shape, situation and look remind us of our own oceans, but again like them, they occupy the greater part of the moon's surface. The seas, or more correctly plains, excited our travellers' curiosity to a very high degree, and they set themselves at once to examine their nature. The astronomer who first gave names to those seas, in all probability was a Frenchman. Hevelius, however, respected them, even Riccioli did not disturb them, and so they have come down to us. Arden laughed heartily at the fancies which they called up, and said the whole thing reminded him of one of those maps of matrimony that he had once seen or read of in the works of Scudery or Cyrano de Bergerac. However, he added, I must say that this map has much more reality in it than could be found in the sentimental maps of the 17th century. In fact, I have no difficulty whatever in calling it the map of life, very neatly divided into two parts, the East and the West, the masculine and the feminine, the women on the right and the men on the left. At such observations, Arden's companions only shrugged their shoulders. A map of the moon in their eyes was a map of the moon, no more, no less. Their romantic friend might view it as he pleased. Nevertheless, their romantic friend was not altogether wrong. Judge a little for yourselves. What is the first sea you find in the hemisphere on the left? The Mare Imbrium or the Rainy Sea, a fit emblem of our human life, beaten by many a pitiless storm. In a corresponding part of the southern hemisphere you see Mare Nubium, the cloudy sea, in which our poor human reason so often gets befogged. Close to this lies Mare Humorum, the sea of humours, where we sail about, the sport of each fitful breeze. Everything by starts and nothing long. Around all, embracing all, lies Oceanus Procelarum, the ocean of tempests, where, engaged in one continuous struggle with the gusty whirlwinds, excited by our own passions or those of others, so few of us escape shipwreck. And when disgusted by the difficulties of life, its deceptions, its treacheries, and all the other miseries that flesh is heir to, where do we too often fly to avoid them? To the Sinus Iridium or the Sinus Roris, that is rainbow gulf and dewy gulf whose glittering lights, alas, give forth no real illumination to guide our stumbling feet, whose sun-tipped pinnacles have less substance than a dream, whose enchanting waters all evaporate before we can lift a cup full to our parched lips. Showers, storms, fogs, rainbows, is not the whole mortal life of man comprised in these 4 words?